Hello everyone, I'm Bradley Sward, and this is my solution to Day 22's problem for the Advent of Code 2024 competition. The problem is called Money Market. I'm solving it again, almost as always, in Python. I think this is an interesting problem when it comes to things I could use for my students in the future. Pseudo-random numbers. We all just think, oh yeah, we just treat them as random numbers as if the computer can actually generate them. But by the end of part two, you figure out that all you need to know is the seed. You need to know a few things. If you know the rules, you can work the system to your advantage, right? So for part one here, I don't even remember what I do anymore. There's a bunch of math going on, and this is basically just the math that's required to create a very simple random number generator, pseudo number generator. I've seen this, something similar to that in the source code for the assembly language code that we use for my assembly language course when it comes to how do they set up random numbers. Very similar, just a simple pattern. It might be even the same thing. I don't know. It's been a while since I've looked. But the idea is you start with a number, you apply these rules to this thing, you prune and you mix, and you'll see that I've removed the function calls from this all I've obfuscated this thing as much as I could just to have some fun with it on my end this time. But anyway, so just to say you mix and you prune and you multiply and you divide, you do all this nonsense, and you get the next number in the chain, and then you use that to get the next number, and it basically kind of, and again, this is something outside of what I understand, the proving part of this, like the research and the proof, that whatever this process gives you, it gives you a random distribution of values when it comes to the numbers that are generated. So just that's the hard part, the proving and the research. So anyway, once you know it works and you've proven it works, then the math itself is relatively simple. This was it only took me a couple minutes to get this thing going, at least for part one. So anyway, so just to say, you just generate the 2000th number for all the things they give you. Like in this case, what's the 2000th number starting from 1 and the 2000th number starting from 10 and so forth and so on. And then you get the number, you get these values, you add them all up and you get that, right? So that's the part here, and I'm supposed to get that number for part one. And coming back here and just running this, you can see that I do generate the values, but just running it again. I didn't do anything for speed here. As you can see, this is the worst line of code in all of mankind, but it works. I was having fun with it, just trying to work it down and just to play and tinker with the language a little bit. But the whole goal here is for part one is basically I'm starting from the first number, and I'm just doing 2,000 times over. I'm generating the next one. And again, I started with having functions, but I wanted to get this all on one page if I could, and I did. And so, generate the next number, generate 2,000 numbers, and at the end of the day, for part one at the very least, part one completes when this is done. So everything else that follows isn't even needed for part one. So it's a very simple, think of all this is going on here. There's not a lot going on for the amount of code that you need to write for part one. So then it just, there you go. There's my number. It generates the number I was expecting to see. There's the number there. So then for part two, now it's a completely different problem basically. So now we're taking the number of or whatever as we're progressing through. We're thinking of each one of the 2,000 numbers you're generating kind of like as a timestamp when it comes to like a market. Something like downtown here around Chicago. The markets and trying to buy and sell. They don't do the same as they did when I was a kid, but it's all electronic now. But anyway, so what you're doing is you're looking through, you're generating the numbers, looking at the last digit of all the numbers, and checking to see what is the difference. Just like any money, you can always see the chart for each stock, and you're like, well, in this case, it went down 3, and it went up 6, and it went down 1, and it went down 1, and so that's great and all. But I have how many different monkeys do I have doing their business here? Let's see, I have 1,506 monkeys apparently doing their jobs of trying to figure out, and we're just trying to figure out if I give them a code, a 4-digit code, like in this case coming down here, if I say, okay, wait until you see a change in the market that shows a decrease in 1, a decrease in 1, nothing changing, and then adding 2, when you see that, you sell and you'll maximize your profit. And the whole thing was for this, well, when you do this, You can only give one code to all the monkeys, or or whatever, however it works out. Yeah, the problem itself, I don't necessarily care about the actual wording of the problem, but they're saying when you see this cell, and then what is, of all the numbers that it could be, because there's 19 different values for each of these guys, right? Because this could go from -9 to +9 with 0 inclusive. So 19 to the 4th power, just to kind of, like, how many calculations am I doing? It's not unreasonable. Sometimes some of these things they give you are very unreasonable, but 19 to the 4th power is 130,000 values. And you're like, okay, well, I only need to try 130,000 different combinations, but I need to try that against the 1,506 different values that I have, right? And then according to that, as we'll see in a second here, I need to multiply that by about, what is it? I'm trying to remember this or the other problem here. Is it about 12 or something like that? Like, I only need to generate about 2 billion possibilities here, which isn't crazy compared to the ungodly amount of things for other problems, especially like that one, day 21, that there were 900 billion different computations to perform. It was just absolutely insane. But anyway, coming back, so that's the idea here, is like, well, which sequence gets me the maximum number of the maximum number of profit? And in this case, the answer is 1,449, and you already saw that it pops up, and we're working toward that here, with the problem here, day 22, part 2. So, but what I'm doing, it's very simple. I mean, as much as the code, it's churning forever. Up there I do have my solution there. It's churning forever. It's taking all the values and creating a secondary, a secondary list that is just showing me the differences between the one value and the previous over and over again. And it's just slower than my previous one, just because, again, I was reducing my goal for this one was to reduce the amount of code, not reduce the amount of time that it took to solve, because it already was quote unquote reasonable. I could go to the washroom, or just go do something around the house for a couple minutes, come back, like in this case, and the problem is solved. And so there's my 1449. So this generates the new one, and then from there we're generating a dictionary. I can show you real quick here. That gets generating the dictionary. Well, it'll take a little while, but once you see that, whatever. So basically, what'll happen here is the first time you see a specific sequence, that's what you keep. And so, like, if you see it more than once, you only keep the first one you see inside of the list. So that's why this is important here. The not in, if it's not already in the dictionary, then put it in with the difference, but the maximum banana count. And then when it's all said and done, I'm just replacing the number with this dictionary for part 2. And so, and we'll get there in a second. It'll be coming up in any minute now here. And so this is just to say, for all the possibilities from 19, for 19, for 19, for 19, go through and try to find, using what we, again, the speed is not what I was going for here. Check to see if if that value, the A, B, C, D, is inside of each of those monkeys' lists. And if so, add them all up. And basically, I'm just trying to figure out what is the best case for all of the monkeys. And in this case, it comes up, I think it's -2110 for my data. That would be the thing that we're waiting to tell the monkeys to do. But if they follow that rule, we maximize our profit at 1,449. I'm surprised it's taking this long to generate. I wasn't paying attention to how long it was generating it before. But anyway, so that's, so again, like, I don't know necessarily how to make this easier and faster. Here we go. So just to say, here's my dictionary, and you can mouse over this one and go, well, yeah, so for this value, you're gonna make 9. If you see this one, you're gonna make 8, and so forth and so on. And if you don't see it at all, you don't add anything at all. So that's why this else 0 is here, that we're adding 0 to the thing. And again, it was just to make this so that it worked in one horrendously unreadable line of code. So that is my solution here for day 22. If you have any questions or concerns, please comment below. Thanks for the 10 of 12 of you who are now watching these videos. As we reach the end here, I'll be making day 23 here right after I'm done with this one. I am 2 problems away from being complete forever, and this is my best year ever, and I'm going to make it perfect. So we're going to do our best to get all 50 stars before the start of the semester. Well, thanks for watching. For any of you who are watching, have a great day, everybody. Take care, and we'll see you later.